Dr. Charlie Smith. I'm Associate Professor of Mathematics at Park University, and this is a tutorial on calculating the mean, the mode, the mid-range, and the mean for raw sample data. Raw data means that we're just working with a list of numbers. That's all it means. Sample data is a collection of data from the population that is not the entire population. Let's start with this data set right here. These numbers in this row right here. In order to calculate the median, the mode, and the mid-range, it is essential as a first step to rearrange the data into numerical order from the lowest to the highest, and preferably from left to right. Rearrange the data into increasing order. Okay. Now, the sample size, that simply tells us how many numbers are in the list. And the sample size is always denoted by lowercase n in statistics. Now, if you count the number of pieces of data that we have in our list, our sample size here is equal to 8. And that will come into play later. All right. The median. Think about the median of a highway. The median of a highway cuts the highway in half, cuts it into 2 equal parts. Well, if we have a set of data like this, the median should cut the data into 2 equal parts. And since the sample size is 8, if we cut it into 2 equal parts, then each part should have 4 items in it. So if I draw a slash mark, say right there, there are 4 items to the left of the mark, and there are 4 items to the right of the mark. So the median should be a number between 14 and 20, and we define it to be the average of the 2 numbers that are closest to the middle in this case. Now, the symbol for the median is x tilde, although in many textbooks you'll see other symbols or signs for the median, but that's the official symbol for the median, x tilde. In this case, we take the average of the 2 numbers that are closest to the middle. So we just take 14 plus 20 and divide all of that by 2, and that should give us 17. So the median of this data is the number 17. Now this was when the sample size is 8, that's an even sample size. What if the sample size happens to be odd? Well, that calls for a different outlook. If the sample size is odd, say 7, here's a data set of size 7, again, the first thing you must do is to rearrange the data into increasing order, into numerical order, from left to right. Now, when the sample size is odd, there will be 1 piece of data right in the middle position. And if you count with your fingers from the inside to the outside, whatever method you want to use, you'll see that this number is right in the middle location. It has 3 numbers to the left of it and 3 numbers to the right of it. So it's right in the middle. And so the median in the case of an odd sample size is that piece of data that's in the middle position. So the median for this set of data is 26. Now let's go back to our original set of data and talk about the mode and the mid-range. The mode is about the easiest thing that you can compute. The mode is the piece of data that occurs most often in the list. It has the highest frequency of occurrence in the list, if there is such. If no piece of data occurs more than once, then we say that the mode does not exist. And if the mode does exist, there can be more than 1 mode if there's a tie for the highest frequency. But here we can easily see that 14 occurs 3 times and no other piece of data occurs more than once. So 14 is the clear winner here. It occurs most often. So our mode is equal to 14. The mid-range is also a simple calculation. It's right in the middle of the range. We just take the smallest piece of data plus the largest piece of data and divide that by 2. This gives us the average of the extreme data values. It's the average of the high and the low. So the smallest piece of data is 12 plus the largest piece of data, 30, and we take their average, so we divide that by 2, and that's 42 over 2, which should be 21, and it is. It's equal to 21. Okay. So that takes care of the median, the mode, the mid-range. What about the mean? Well, the word mean simply means average. And everybody knows how to compute an average. But in the notation of statistics, the symbol for the mean is X bar. If we call these X items, we call these values X values, then the mean of the X values is called X bar. And it's calculated just as you would calculate any average. You add up the items that you have, that's the summation of the X values, and then you divide by the number of items in the list. Well, that's our sample size. That's our sample size n. Excuse me. So adding up the numbers in this list, and these are the numbers. This is the same. This is the first data set that I started. I've put them in a column for reasons that you'll see later on a future tutorial when we talk about the variance and the standard deviation. This is just for convenience for later on. So putting these in a column like so, you simply add up the numbers in the column and you get 150. Now recall that our sample size n is equal to 8. And this calculation here tells us that summation of x is equal to 150. So the average of the data is summation of x, 150, divided by n, 8. And this gives us an exact average of 18.75. That's all, folks.